Okay, let's solve the inequality x to the power 4 plus 3x squared minus 28 is less than 0. Right, so if we were trying to look at something like this, let's call all of this f of x. Okay, so f of x is equal to x to the power 4 plus 3x squared minus 28. Right? And if you want to solve an inequality, the first thing you have to really do is you got to factor it out fully. So if I want to factor this out fully, what you want to do here is let's look at the integral zero theorem. And in this case, I can basically postulate some potential factors. So the potential factors here are the factors of the constant 28. So factors of 28 include 1, 2, 4, 7, 14, and 28. And I can also look at factors of the leading coefficient. There's a 1 here, so I'm going to do plus minus 1. Okay, so those are your potential factors. And what you got to do is you got to test some of these out, right? So you're going to have to do trial and error. So we actually find out that f of 2 is equal to 0, right? And once it's equal to 0, you can use factor theorem. X minus 2 is a factor. So because x minus 2 is a factor, you also need to figure out another factor because it is to the power of 4. You can either use synthetic twice or you can do long division. Well, I also found out that f of negative 2 is also a factor. Right, so this tells us, according to factor theorem, x plus 2 is a factor. So collectively, x minus 2 and x plus 2 are factors. If I find the product of this, you can also find that x squared minus 4 is a factor of this expression. Now, if we take this expression and we do long division, right, so you have x to the power 4 plus 3x squared minus 28, and you divide this by x squared minus 4, right? If you take this and you divide it by your divisor, you can actually get a quotient that is x squared, right? So I want to match the leading term. I'm going to multiply this by x squared. So you get x to the power 4 minus 4x squared. I'm going to subtract these two, right? It cancels out. You get 3x squared minus 4x squared, which is 7x squared minus 28. I'm going to bring this guy down. And then I'm going to match the leading term again. So I'm going to multiply this by plus 7. So you get 7x squared minus 28. And this is your quotient, right? So after you have your quotient, you can notice that x squared plus 7 isn't factorable, right? So you have x squared minus 4 times x squared plus 7. You can refactor this as x plus 2 times x minus 2, x squared plus 7. And this is your new inequality, okay? So now I'm going to work with this inequality. Just going to use a different color here. All right, so this is the inequality I'm going to be working with. And the next thing I want to do here is find my critical numbers. So to find critical numbers, you're going to set this expression, right? Let f of x equal 0, because critical numbers include x-intercepts, right? And if you do that, you can see that x can be equal to negative 2 or positive 2. So using these values, I'm going to plot them on a number line. And the reason we plot this on a number line is because critical numbers can be used to determine the intervals, right? So that we're going to be looking at. So this is negative infinity, this is positive infinity, this is negative 2, this is positive 2, right? And one of your intervals here is negative infinity and negative 2. The other interval is negative 2 and 2. And the interval here is 2 and positive infinity. Okay. Using that, what we're going to do here is create a table of intervals, right? So I'm going to do that out here. Okay, and in your table of intervals, actually, you know what? Let's make some space here. Okay, so in your table of intervals, you want to place your intervals on top here. You usually have one more interval than critical number. You have negative 2 and 2 here, and 2 and positive infinity here. X belongs to each of these intervals, and then you can write down each of the factors here. Okay, so if you look at the factors, right, if you look at the factors, one of your factors here is x minus 2, the other factor here is x plus 2, the other factor is x squared plus 7, but this will always be positive. Doesn't matter what value of x you plug in, it will always be positive, so we don't have to assess that. We'll call this collectively f of x, and you're figuring out when f of x is less than 0. So within each interval, I'm going to test a series of values. So between negative infinity and negative 2, I'm going to let x equal -3. So if you do -3, you get negative, negative, and then this is positive. Between -2 and 2, I'm going to let x equal 0. So you get negative, positive, right? This is going to give you negative. And here you're going to get x equal 3. You're going to get positive, positive, and positive. So this is going to be greater than 0, less than 0, greater than 0. So the solution here is just this interval, -2 and 2. So therefore, x can belong to -2 and 2, and then f of x, or this inequality, will stay true.